Welcome to qnawire.
This is problem number 10 of the Stewart Calculus 8th edition, section 2.8. Trace or copy the graph of the given function f. Assume that the axes have equal scales. Then use the method of example 1 to sketch the graph of f prime below it. So we have copied here the graph of the function f given with this problem, and it has this shape shown here in blue, and we're going to graph the derivative of this graph f prime in red. We want to identify certain parts of the graph of f that are special, and then determine what the derivative is at each of those points, and then come to a conclusion about what the derivative function looks like. So here we have identified a few points that we want to line up for the graph of the derivative of f. Let's graph some easy points first. There's a horizontal tangent line here at this point, at this first special point, which we want to draw here as a zero slope on the f derivative graph. And this also f prime graph, and this also occurs over here. There's another minimum. This is an inflection point up here, and then this is a minimum down here. And those both correspond with the slope of 0. So f prime is 0 at those points. Then we ask ourselves what's happening in between each of these sections. To the left of this first 0, we have a function that has very negative slopes that get less negative as they approach 0. So what that means is that the derivative function is below the x-axis as it approaches 0, so it's more negative, then it becomes less negative towards this point. Yes, and it'll look like this. Next, between this first x-intercept on the f prime graph and x equals 0, we want to ask what's going on. This is an inflection point, which means that the function or the slopes don't change from negative to positive. In fact, they remain negative. It goes from 0 to something that a slope of a tangent line that's negative to increasingly more negative, a maximum negative derivative at x equals 0. So we'll show this as still some negative slopes reaching a minimum here at x equals 0. So the slope is steepest here at x equals 0, but then the slopes become less negative as it approaches the next special point. So what this means is that the slope comes back up and then reaches the point of 0 slope here at the second special point. And then afterward, the slope goes from 0 and increases positively towards a very positive slope for the tangent lines, meaning that it will just keep increasing afterward. So this graph of f prime is consistent with all of the slopes of the tangent lines of the graph of f, meaning that this is an accurate sketch for the graph of f prime.